And,
Did you have any questions about the preparation?
nothing really. I had a little bit of a struggle getting like the Excel program to work, one that we were like supposed to download. Did you download that program?
I didn't actually. I was just relying on the hand math because I don't know. I guess I'm not that good with computers.
I hear you. That's kind of how I've been doing it too, because I struggled with it. But
And there's not.
yeah,
It's not super in depth by hand.
yeah.
But
It's kind of what we've been doing, right?
yeah, exactly. Just like last lesson, this is pretty much the same that we've already learned, just switching the variables.
Okay, that's cool.
Yeah, it's pretty nice. Let's see if we can get the margin of error for this chapter, though. I mean,
Yeah, hopefully we can master it for once.
yeah, I think I've got it for this lesson. We'll see, though.
Okay, well, good. Yeah, I mean, I worked on it, so hopefully I can do it too.
Yeah.
Great. Should we jump in to the quiz then?
Let's go ahead and do it.
Okay. Thanks for wanting to do the video a little bit later today. It was helpful.
Oh, kidding me? I've made you do the video at like 9 o'clock or 9:30. I don't remember what it was.
Oh, that's all good.
And my schedule is pretty free, so I'm all good for any time you need to change anything. Just let me know.
Alrighty, thank you. My wife and I we went on a date. We went to the planetarium.
So. Really? I have always wanted to go to that. How was it?
It's really fun.
Yeah?
Some of the videos are kind of cheesy sometimes.
I bet. What's this month?
But it's real fun. It's Stars of the Pharaohs, I think it's called.
Oh.
But, so I don't know, it's pretty cool.
Yeah.
Like,
I've never been to a planetarium before, so
yeah, we like it. We'd probably recommend it.
There you go. You can also go, I haven't done this yet, but you can also go to the observatory in the Romney building.
Yeah, we went up there tonight as well.
Oh, really? Very astronomical night for you both.
Yeah, that's right. Yeah, we just saw the Andromeda Galaxy, I think it was.
No way.
Yeah.
That's so cool. Yeah, man, space is awesome.
Yeah, I agree. Yeah, you guys should go. I think they're open from 7 to 10.
Okay. Yeah, we'll probably go next week or something like that. Hey, my brother and to-be sister-in-law are coming next Thursday. Maybe they'll come with us.
Hey, are they gonna get married?
Yeah, they're getting married in like a year from now, though.
Okay.
Yeah.
Gotcha. So long engagement?
Yeah, he's non-active and she's not a member. So they're not all about that Mormon timeline thing.
I gotcha.
Yeah.
Is he an older brother or a younger
brother? He is 28 and I'm 22. Okay. He's my oldest brother, second to oldest sibling.
Okay.
Yeah.
Gotcha.
So.
Cool.
Yeah.
That's cool. That'd be a fun date for you guys.
Yeah, hopefully. Perfect. All right. So, were able to get the quiz pulled up?
Yeah, I'm just on question 3 here.
Awesome. The symbol for the true population proportion is which of the following?
I believe it's P, right?
Yeah, I think so. Now, this is something that I kind of had a little trouble with, was trying to figure out when to use p hat and when to use p in the equations. So maybe you can help me out with that.
Yeah, I don't know. I'm all about memorizing equations. So my wife, like, she tries to help me, like, understand what's going on, but.
Right. Yeah. Well, that's no problem. We'll see if we can get it together then.
Yeah. Okay. For the next 2 questions, suppose n equals 100, p equals 0.25, and p hat equals 0.10 or 0.10. The requirement for constructing a confidence interval, are they satisfied?
All right. So we use p hat for this one, right?
I think so. I'm just pulling up the equation really fast.
Okay, no problem.
So it has to be greater than or equal to 10, right?
Yeah. I didn't write it down anywhere else except for using the p hat.
Yeah,
But
I mean, that sounds familiar. Just want to make sure here. Yeah, you're probably right. Awesome.
okay.
So, ooh, actually here it's a p.
Just p?
Actually. Yeah, so n times p, and then n times 1 minus p. That's what, I don't know. That's what
Yeah.
it says here, but
Yeah, it makes sense. I just don't know when to use which one.
yeah. So guess I'm not very helpful there.
I did the equation for both p and p hat.
Okay.
And it looks like it satisfies both.
Okay. Awesome. Yeah.
Because 1 times 0.10 is 10, and 1 times 0.9 is 90, times 0.25 is 25, and then 0.75 is 75.
Okay. Awesome. Well, thank you. I took me that long to just find the equation.
Oh, okay. This question, this might clear some things up for me. So the next one, it's just asking, are the requirements for the hypothesis test met? So I think this is the difference between using p and p hat. Confidence interval.
Gotcha. So for this one, the hypothesis test, I don't remember what to do with that. Is it just how do we?
It's going to be the same equation. Just one uses p hat and one uses p.
Okay.
I think I'm figuring this out now. So the confidence interval one, that's the lesson we went over today, and that is p hat. But the lesson from Tuesday, which is dealing with hypothesis testing, is the equation that you mentioned, the p.
The p. Okay, I got you. That makes sense.
Cool. Okay. Well, that clears up that question then.
There you go.
Yeah.
You're good. Okay. Alrighty. So this one would be true then.
Yeah, it would be.
Okay.
All right. Now, a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find the p-hat, the point estimate of the find p-hat or the point estimate of the proportion of first-degree murder defendants who were found guilty in this.
Okay. So that's just 45 divided by 60?
Exactly. For that, I get 0.75.
Okay, well, I assume that's true. My calculator's still pulling up.
So you're fine.
I'm like the slowest group member. I'm sorry. I keep you up.
At the same time, you're the fastest of my group members.
That is true. I can't claim that. Okay, 45 divided by 60. Okay, yeah, 0.75. I got the same answer.
Perfect.
Okay, create a 95% confidence interval for the true proportion of first-degree murder trials. There, the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. So the first one would be the margin of error for the 95% confidence interval.
What's the equation that you have for the margin of error for this?
I have right here. Sorry, pulled the wrong one. So, I think it's just right here. Okay, sorry.
Oh,
I'm just looking in the assignment.
You're fine. I just want to make sure that I,
You have it written down correctly? Or?
yeah, well, especially since it's the margin of error, I kind of have a little personal relationship with that concept.
Yeah. Okay, I just remember it's down near the bottom here. Almost there. Okay, so if m equals the z star, and then the square root of times the square root of p times 1 minus p all over n.
Okay, perfect. So we've got the same formula. Okay.
So p in this case, would that be that wouldn't be the 0.75, would it?
I was just trying to figure that out because it wouldn't be. It would be the other p.
Yeah. That's what I was thinking.
Which is the population proportion.
Yeah.
And the mean of p hat equals p.
So p is
I don't know. Maybe it is p hat that we would use in the equation, but it doesn't seem like it would be.
yeah.
I guess I just don't know how to find p if it's. I mean, it doesn't. I don't feel like it's given anywhere.
Yeah, I don't either. Should we just try p hat?
Yeah, that sounds good.
Okay.
And this is 95%.
Yeah. I was talking to a girl today that flunked out of this class.
Oh, really?
Yeah. She's like, that class was so hard. I think it's too bad if you stay on top of it.
Yeah, much better than chemistry, that's for sure.
Yeah.
I
Yeah.
feel like that's probably the case with a lot of even chemistry. If you stay on top of it, it's doable. I just have a hard time staying on top of chemistry, I guess.
Yeah. There's a lot to absorb.
Yeah, it's true.
Yeah. Did you get?
All right.
Do you have an answer there?
Yeah, I got decimal places, 3.110.
Yeah. Okay, that's what I got as well.
Okay, perfect. At least we can follow the steps right. And then it would be 0.75 plus or minus 0.110.
For the upper and lower bound?
Yeah.
Yeah, I think so.
Okay.
Because, yeah, we don't have to throw in the whole equation.
Right. For the lower bound, did you get 0.64?
I haven't finished it yet, but
Oh, okay.
sorry. Yeah, that's what I got. And
Okay.
then for the other one, did you get 0.85?
I got 0.86.
Okay. So was it 0.74 plus 0.110?
0.75.
75. That's the difference there. Oh yeah, it's the wrong number. Okay.
That would make up that difference though.
Yeah. Okay, so lower 0.64.
So if you were to increase the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval?
That would decrease, right?
Yeah, I think so. Which
Okay.
logically makes sense. The more people you survey, the more likely it's to represent the population.
Yeah, that does make sense. You're right.
So the more accurate it's going to be.
Yeah. Awesome. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest n can be, and both requirements still be met?
So for one of them, for the one that's NP equals or is greater than or equal to 10, N has to be at least 20, but I don't know if it satisfies the other requirement. But let's go ahead and see.
Okay. For this one, we use the equation the n equals z star over n squared.
No, for this one, I think we can just do NP hat
Oh, okay.
is greater than or equal to 10, and then N times 1 minus P is greater than or equal to 10.
Okay.
I think.
Um,
Yeah, because it doesn't give us the Z at all, and that would be we would need that.
Yeah.
Or M.
Okay.
So I think you're still working, but I got 20 as my answer.
Okay. Yeah, that makes sense. So it would be met then. Wait, what is the smallest? The smallest n can be in your requirement. That is the answer. Then it's 20.
Right, right. Because
Smallest
if you plug them both into the equation, actually both equal 10.
Okay.
Yeah.
Okay.
Oops.
Awesome.
What did I push?
Yeah, 20 times 1/2 is equal to 10. Yeah, okay. Perfect.
Sweet. All right. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/10. What is the smallest N can be? And both requirements still be met. Same question, just a different P value.
Yeah. Good. So how do you go about doing these ones? Do you just plug in different values until?
Well, I kind of thought about the equation and the numbers that were given. So if you were to look at the equation, let's look at 11 since we already have our answer.
Mm-hmm.
P is 1/2 or 0.5. So N times 0.5 has to be greater than or equal to 10. And if you're trying to find the smallest that it could be, then you would look for equal to 10.
Yeah.
So if you just switch it to an equal sign, it's x times 0.5 equals 10. If you take the 0.5 over, that you multiply 0.5 times 10, that's 20.
Okay.
And then you can kind of check your work by doing the second equation. And it probably should work with that, although I'm sure there's an example where it doesn't.
Okay. Awesome. Well, that makes sense. Thank you for helping me understand.
Mm-hmm. And so for the second one, what was that?
Just do a little bit of algebra.
Yeah, exactly. And so for the second one here, you can look at P is 0.1, and 0.1 times 10. Wait. Is that right? Okay. I have to think about this one.
Okay.
Oh, sorry. You wouldn't multiply both sides by 0.5. You would divide by 0.5. So
Okay.
in this case, you would do like 10 divided by 0.1. And that's kind of just to get an estimate of where you want to start off.
Okay. All right. So for that one, it'd be 100.
Yeah, exactly. Then if you do the second equation, it works out as well.
Okay.
Yeah. So I think generally the N times P is greater than or equal to 10. It's going to be the one you want to look at because that will give you the smallest of the two answers if they are different.
Okay. All right.
No, I'm not sure about that, but I think that's what it is.
Sounds reasonable. I'm gonna play around with that a little bit later. But
Okay, yeah, absolutely.
I don't remember whose turn it is, but I can read this one. So
All right.
use the following information for the next 6 questions. For the water quality study in the reading, about 60% of the water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a significance level of 0.5, 0.05 with the following hypotheses. The null being 0.6 or equaling 0.6 and the alternative being less than 0.6. We collect new data, and this time 80 and 38 indicate good. The conditions for conducting hypothesis test are satisfied.
Okay. So I have a question for this one. Since this is a hypothesis test and not confidence interval, would we use the p-value for figuring out if the hypothesis test conditions are satisfiable?
That's kind of what you were thinking, isn't it?
Yeah, I'm just not sure if it's
But,
right.
yeah, I'm not sure either. But I do have the book opened up.
Okay.
So,
While you're looking that up, I'm just going to go through both possibilities and see.
okay, go for it. Thank you.
Uh-huh.
Yeah, so for this one, it would be P.
Oh,
You're right.
okay. Perfect.
Yeah, so n times P greater than or equal to 10, and then the other equation.
Sweet. So for this, I just did 0.6, or the p-value, times 80. And then 80 times 1 minus 0.6. And both of those were above 10.
Okay, perfect.
That would be true.
Mm-hmm. Right. So 38 divided by 80. So,
Yes. Yep.
okay, I got 0.475.
Same. Oops. Looking for the test statistic. Okay. Would in this equation on the top, it has p hat minus p naught, or the null hypothesis. That would be 0.6, right?
I don't know. Sorry.
Oh, you're fine. I think it is
It is.
0.475 minus 0.6 on the top.
Okay. Okay. Gotcha. Because that's P and then P hat.
So it's
Yeah.
p hat minus p.
P hat minus.
Yeah. Or it. Yeah. Yeah.
Okay. Sorry. It's always like a refresher. Every time we have these videos, I have to like totally remember what I've just barely learned.
No, I hear that. That's for sure. What's the sample size for this again?
It is 80.
Oh, okay. Perfect. 80. Okay.
So the test statistic formula
Mm-hmm.
is that so p hat minus p all over the standard deviation.
Yeah, exactly.
Okay.
Exactly.
So we probably have it all worked out.
Almost.
Did you get a negative value?
Oh, I should have. That's my problem. I accidentally put positive 285 instead of negative 285. I mean 0.285 at the top. But yeah, I think it should be negative because it was 0.475 minus 0.6. Did you get minus 5.203?
No, I didn't.
Let me make sure I go through
Yeah,
it.
I want to make sure I'm doing my right too. Okay, what was our? I just want to make sure I have the right answers here. Yeah. Oh, okay. That's probably why. What did you get
use a
again?
different p-value?
I did.
I used 0.6 in this.
0.6.
Yeah, because the test statistic, it refers back to the null hypothesis when you're using the p-value, in which case it would be 0.6.
Okay. Awesome. Well, I don't know. I'm getting. I got negative 2.282.
That when you redid it just then?
Yeah.
Oh, okay. I got negative 5.203.
Okay. How did you set up your formula? I just want to.
So I've got up on the top of the equation 0.475 minus 0.6. All of that divided by the square root of, and then on the top, 0.6 times 1 minus 0.6. All of that divided by 80.
That is exactly what I have.
Huh, maybe I put something wrong in my calculator then.
Oh no, maybe I did. We probably did. So, I'm just trying to figure out what I did here. Cool.
Yeah, I get the same answer again.
Okay. Well, let's just go through this because
Okay.
consistent. So
minus
Negative.
5.203.
Okay. Okay, and what is the p-value? Okay.
Is this where we use the applet?
Yeah, I believe so.
Okay.
Yep, this goes in as the z-score, right?
Exactly.
And then, yep. Since this one was this one two-tailed?
It was not. It's asking for, or it's looking at less than.
Less than.
Yep. For this, I actually get pretty much 0.
What was the z-score again, or the t-score?
The z-score was minus 5.203.
Oh yeah. Yeah, that's a pretty small number.
Yeah.
If you get 9.8048 times 10 to the negative 8.
Yeah, that's what I have.
Okay.
So would we put 0 or that actual number?
I'm trying to remember. So before, when we put like 0.00000, like 6 zeros and then 3 for the p-value.
I don't remember actually.
I don't know, that may have been something I missed on the test, but I just remember doing that.
Right. It very well could be. I mean, in which case we can definitely try both of them out.
Yeah, maybe I don't know. Or you can just throw 0 on yours, maybe, if that's what you're going to do. No.
If you write out all the zeros, there should be 7 zeros before the 9. All right, and then what is the decision for the test when the significance of 0.05 is alpha?
Wait, what was that? Sorry.
So we're just looking for what decision we would make for the test. And
Okay.
alpha is 0.05.
Okay.
So I think,
And so we would reject it, right?
yeah, I think so. In which case, in 18, we can say that, would it be D for this one?
Yeah, I think so.
Okay, sounds good. Well, I'm going to go ahead and submit mine, see what we missed.
Okay, that'd be great. Thank you.
Yeah, no problem. We missed 2, one of which was number 16, and the other was 15, which would change 16.
15 and 16?
Yeah.
I wonder. Let me try this.
I'm going to open my quiz back up here.
Okay. Whenever you're ready, I can give you the answers.
Okay.
I don't
3
know.
was, huh?
3 here. I'm pulling it up.
Oh, okay, sorry.
Here it is. So it's P.
P. Okay, 4.
4 is true.
5.
True.
6.
0.75.
7.
0.110.
Okay, just realized we got the margin of error right.
Hey, good job.
Number 8.
There you go. 0.64.
9.
0.85.
10.
Decrease.
11.
10.
12.
100.
13.
13 is true.
14.
0.475.
17.
Reject the null.
18 was D, right?
That's right.
Okay, perfect.
So, I don't know why, but the test statistic, I don't know. I got negative 2.282, and I threw that in the applet, and it gave us a number that wasn't so extreme as
Oh,
a
really?
value. But I still don't know if I calculated that correctly. I mean,
right. I mean, chances are very good. Did you get 0.0112 as the area?
yeah.
Okay. So P hat, which is 0.475 minus P naught, which is 0.6, divided by 0.6 times 1 minus 0.6, or 0.4, divided by 80. I'm going to try to see if I can get that negative 2.282.
Okay.
0.475 minus 0.6. Okay, I already have a different answer, and I just did one step. Okay. Oh. I got negative 2.82. Looks like that's the answer.
Awesome.
I'm really glad I was able to my mistake there. So what I did was I multiplied 0.475 by 0.6 instead of subtracted it.
Oh, gotcha. Okay.
Yeah. Good
That's
thing.
totally fine.
Yeah. Good thing you got that though.
And then 16 we got wrong as well, right?
Yeah. And this was the area in the applet, which was 0.011, right?
Yeah.
Okay. Sweet.
So, 0.011. Yeah. Well, I'm gonna submit mine really fast.
Okay. Sounds
See
good.
how we do.
I feel confident in your answers.
Well, most of these are your answers actually, so.
Well, I don't know about that.
Okay, so looks like. Ooh, I must have put something in there wrong because I got a 92.11, so.
Huh, which one did you miss?
I missed 11. I must have put something in there wrong.
Oh, perhaps.
What was our answer for 11?
It was 10.
Okay, that's what I put, and I got it wrong for some reason.
Really?
Yeah.
That's really strange. Oh, wait, no, it's 20.
It's 20. Okay.
Now that I think about the answer, yeah.
Okay. Sorry about that. I didn't mean to.
You're-
I would have made you miss that one too.
You're all good. I would have happily taken a 92.
Yeah. Alrighty. Well, I'll just go in and I can throw that answer in there.
Are you sure? I can go over it if you wanted me to. I could give you the answers.
Are you sure?
Oh, yeah, that's no problem at all.
Okay. Just give me 1 second. I'll open it back
Okay.
up. Thank you. Also, that big assignment that's due on Saturday.
Oh, yeah, I completely forgot about that.
Yeah. It's gonna be hard for us because there's only 2 in our group.
Yeah. Now, I did notice that there was another group of 2 that meets in the evenings. So I might, if you wanted to, I could email our teacher to see if we could pair up with them.
That would be really helpful.
Okay, I'll shoot her an email tonight.
Thank you.
Yeah. Because, yeah, Sasha was telling me that the project with just us 2 would be a lot of work.
Yeah. I was reading through it, and there's like, you got to make a PowerPoint, you got to like design the whole study, and, like,
Jeez.
there's just like tons of steps.
Yeah.
Okay.
Excuse me. Sorry.
No, you're good. Most people would not be doing homework right now, so it's amazing you're still awake.
I didn't do anything all day. I didn't have class today. And so I usually prepare for this class right or the day of our assignment, our meetings.
Mm-hmm.
But I just procrastinated and procrastinated. I didn't get done with the preparation assignment till like 8:20.
Oh, really?
So, I mean, I have done nothing today to be tired. I don't know why.
Oh, you're good. Don't worry. Okay, so for 3, it was P, right?
Correct.
4 is true.
Yep.
5.
True.
6.
0.75.
Okay. 7.
0.110.
8.
0.64.
9.
0.85.
10.
Decrease.
Computer. 11.
20.
Oh yeah, that's the one I missed. 12.
100.
13.
True.
14.
0.475.
Okay, and 15.
I think I wrote this one in here wrong. Okay, yeah. Phew, good thing we're going over this. Minus 2.282.
2, 8.
I was slightly dyslexic and wrote minus 2.828. So I think we're going over it.
Yeah, that is good.
Yeah.
16.
0.011.
All right, 17.
Reject.
18.
D.
Okay. Alrighty.
All right, let me submit this. See, just triple check, make sure we're getting that uno hundrero. No, whoa, wait a second.
Wait, really?
We,
I hope I didn't tell you another number wrong.
I don't know.
I'm really
Okay, it was
sorry.
number 9. We could have gotten this one wrong before, and I just didn't realize it.
But I didn't see it when I just submitted my quiz.
Huh, let me go back to my submission of the first assignment, because you can look at your answers,
Yeah.
I think.
Did you have 0.85?
Yeah, I did.
Okay.
User progress. No, that's not what I wanted. Grades.
It's really interesting. Because 8's correct.
Yeah. Was 8.68.
8 was 0.64.
64. I don't know. Maybe I can't pull it up.
Okay.
I know Sasha
Yeah.
can pull hers up. Maybe it's because she's already finished. Oh, maybe. Maybe I can actually. There we go. Okay. Oh, okay. So 9 is 0.86.
Really?
Yeah.
It's my fault. I am very sorry.
Are you kidding me? I will for sure take the 97.37%.
Okay, well, I'm just going to submit mine.
Okay.
Just the way it is.
And that in no way hurts my grade at all. I'll take it. In fact, it helps out my grade. So
Man. But
that's
I'm sorry.
not a worry.
There we go.
Sweet. Finished all my homework for the day. That's always a good feeling.
That's good. Especially if you have a big load, it's really nice to be like on top of things.
Oh, yeah.
Okay, so what do you want to do about that other assignment? You said that you shoot an email.
Yeah, and then this is my procrastinating self again. I haven't even looked at the assignment. I don't know what we do at all.
That's okay.
So I can read over that, and then maybe we could correspond tomorrow.
Yeah, that's what I was thinking too. There's like, I think there are like 6 sections, and so it would be nice if like, if we had a big group. If we could get that other group, that would be really helpful.
Yeah, absolutely. I'll let you know what she says then.
Okay, thank you.
Yep.
If by chance, like, you can, if you're busy or something, just let me know and I can write her too.
Okay. I'll just go ahead and do it right now.
Okay. Awesome. Well then, yeah, we can just keep in touch tomorrow then.
Yep, sounds good.
Okay. Alrighty.
Alrighty. See ya.
Yeah, we'll talk to you later.